Welcome to Vegas Programmers. Sorry, I'm going to repeat myself a little bit because we weren't recording the original intro. Today we have Shane Mitchell doing a talk on cybersecurity for developers. Super excited for this talk because it's not just a boring old cybersecurity talk. And I'm sure coming from a perspective of a developer, which Shane and I used to actually work together, will be very interesting because I personally work on a lot of things InfoSec related now, and it makes me want to tear my hair out. So hopefully, and I'm sure I will, get some tidbits out of this talk that I can probably bring to my day job. So thank you very much for doing the talk. Couple of things. One, we will be giving out a JetBrains 1-year free license at the end. So they sponsor the meetup with licenses to give away. So thanks to them. We also do have a 1-month SymphonyCast membership to give away as well at the end. So stick around for that. And maybe next month, I'm not 100% sure, I gotta lock it in, but we might be having a talk about Python and computer vision. However, we love when audience members either want to do a talk or suggest a talk. Better to actually do the talk yourself. Even if it's you coming from a perspective of a junior developer, we love talks from all skill ranges. And it's not just, has to be about a particular language. Originally, this was PHP Vegas. We had to branch it to just general programming because we were talking about all kinds of things, JavaScript, AWS, and all those good things. And today, cybersecurity. We haven't had a cybersecurity in a long time. Shane leads the OWASP chapter out here in Vegas, which is awesome. Get me free tickets to DEF CON, man. What the heck? So, all right, without further ado, Shane Mitchell.
Thank you. All right, well, hello, everybody. Thank you guys for joining. Hopefully, tonight, you guys get a sneak peek at the life of cybersecurity and what it means from a developer's perspective. So, personally, I believe that developers are a big gap, right? There's a huge niche in the cybersecurity space that is unfilled. And the answer currently is bolt on this app, put this app on top, bolt on that app. And it's never going to be as good. Developers, as we go through this talk, I think have an intrinsic part in how to make an application or a product or an environment even secure and more secure, right? The coordination with developers is paramount to a secure product, right? And I like to start with a little quote. Most people have heard of this quote, although it's often misattributed. An ounce of prevention is worth a pound of cure. Right? Many people have heard this quote, raise your hand if you've heard that before. Do you know who actually wrote that quote? It wasn't Benjamin Franklin. Everybody refers to him, but it's actually some French guy with a really long name. I'm not even going to mispronounce it. But really, that quote highlights the concept that I want to bring forth today with tonight's talk, right? We do need things that like the traditional cybersecurity industry provides, like a SOC team, right? They're important for their own reasons, right? But who knows what a SOC team is? Anybody knows a SOC team? Security Operations Center, right? Those are the guys that are watching logs and looking for the guy there's somebody in there. They're currently, running a ransomware and we're starting to lose access to systems, right? They're the guys monitoring. They're the police of the digital environment, so to say, right? They're good. They're a prevention, right? They're there to follow up after. They're there to cure a disease when what we need is a vaccine, right? We need to prevent the ability for them to get in the first place, right? So a couple more quotes that help highlight this concept, right? I think they really do a good job of depicting the concept. Traditionally, network engineers are the path into a cybersecurity role, right? Most of the certifications, the early certifications you would get on your way to a path in a cybersecurity job role usually are network focused, right? The Network Plus or whatever, certification a lot of you might have heard of, right? Really, unless you want to be like a SOC analyst, or like the popular craze right now is like a pen tester. Everybody wants to be a pen tester. Trust me, it's not what it seems like. Grass is always greener from the other side. I'll just say that. But those job roles historically have been the only avenue into information security that wasn't from a networking perspective, right? Like that was networking, or that was cybersecurity, right? Either you're securing the network, you're monitoring the network, or you're doing a penetration test, and that was cybersecurity, right? Outside of that, maybe the authentication portion, right? Making sure you are who you say you are. That is security. That's traditionally what encompasses the major viewpoint for security from an organization perspective, right? Everything beyond that is really just seen as a very complex unknown, and it's too much effort to really secure it. So let's just bolt this thing on top, because they said if we pay $3 million and bolt it on, then it's going to make our environment secure, right? It's never really the case. They often do a lot of help out of the box, but they're not bulletproof by any means, right? However, software developers, they spend their time, their days are focused purely on computer logic, machine logic, right? Understanding how this application is meant to work, the types of information and the flows of information that the application they're building is expecting, right? So I really feel that developer insight, that very specific detail that only a developer is going to have regarding an application is a key to ensuring that application is secured or can be secured properly, right? So scientists study the world as it is, but engineers create the world that has never been, right? Similar concept here. Scientists discovers a new type of material or energy, and the engineer discovers a new use for it, right? So I think this is a good way to view a developer or an engineer's position, right? We're just engineers, right? And we're often finding new ways to do things. A pen tester, a hacker, they're just an engineer, right? They're just trying to find new ways to do something that no one else has done, right? It takes that similar mindset to protect against it, right? Not a bolted-on product, right? I've been a developer for a long time. I've worked in a lot of code bases, various languages, various verticals, industries. I've had to adhere to a lot of different, security and compliance frameworks and stuff. In that time, I've really come to the belief that if developers were a lot more involved with the cybersecurity of the rest of the IT processes, we would have an overall more secure environment, right? Breaches are a lot more common than they should be, right? Here's random statistics. Everybody likes statistics. They're a little bit old if you're reading this stuff on here, but they're all legitimate information, right? When you're trying to understand the breadth of an issue that is cybersecurity, right? Most of the time, the public doesn't even know about major breaches, right? What benefit does Google and Microsoft have to make public announcements every time there's some breach of 6 million records or 20 million records, right? In 2024, there was a breach called Mother of All Breaches. I didn't even know about this until I read it, and I'm in the cybersecurity space, right? Like, a lot of people don't know about these big breaches. That exposed over 26 billion records with a B, including some from Twitter, Adobe, Canva, LinkedIn, and Dropbox, right? There's no hacker organization that's claimed responsibility for that, right? That means it's probably a nation-state actor or something else, right? They're retailing that information on the side, right? But there's a lot of value from a hacker's perspective, right? That's why it's so prevalent. Also in 2024, in August, there was one of the largest security breaches ever, involved a background check broker called the National Public Data. And that exposed the personal information of 3 billion people. That's a lot. That's full information on your identity, right? That's almost 3 million records they could steal all 3 million people's identity. Full names, social security numbers, all of that stuff, right? But chances are nobody in this room probably heard about that breach, right? Cyber breaches, they're of significant concern, right? 95% of security breaches are defined with the root cause of human error, which indicates that they're likely preventable through some sort of education or maybe the application having proper attribution to edge case testing and having security as part of a test suite and all of that, making sure the developers are actually provided the opportunity and prioritizing security as a core feature of an app and not something that hopefully we can get to it, you know? In 2024, the average cost of a data breach in the US was $4.8 million. And the highest, that was wrong. It was 9.36 million. The average total of a data breach in the US in 2024 was $9.36 million. That's a lot of money for an average breach. When you're not able, when you're not able to defend your own app, right? You're not able to protect your own app. There's nothing you could do as a developer, right? We need to fix this, right? But how do we fix this, right? There's a lot goes to it, right? But before I jump in too far, because I'm already getting into it, right? Who am I? My name's Shane Mitchell. Currently, I'm the Senior IT Security Architect for Boyd Gaming. I focus on application and cloud security mostly. I'm also, as Josh said, the chapter leader for the OWASP Las Vegas chapter. I've been a software developer for over 10 years. I've spent most of my career as a software developer. I was offered an opportunity to join a security architecture position for a large company. Wasn't sure how I felt about it at first, right? The company I was at was providing a lot of stress. I know I tend to be a more security-focused developer. I often helped with the Las Vegas chapter, or the Las Vegas OS chapter. I wasn't quite a leader. It was about the time I became a leader. I'm not sure which one came first. But I became a chapter leader at OWASP Las Vegas and joined Boyd Gaming as an application security architect. Once I joined that cybersecurity space and really had to start digging into all of the things that is cybersecurity, right? I quickly learned that there's a lot going on, and I had to quickly learn, like, what's a CVE, what's a CWE, what's what's threat modeling and all that stuff, right? Really, there's so many acronyms in the cybersecurity space. It's ridiculous. It really is. We're actually going to make fun of that or touch on that in a little bit. But yeah, there's way too many acronyms in the cybersecurity space. So where do you start, right? We just start with basic concepts of application security, right? So most developers, junior developers even, can probably read and get a rough idea of the point that we're trying to make with these simple items here, right? You want to secure your code by design. You want to make sure that you're designing your code, your app, to be secure. So what does that mean, really, right? In the cybersecurity space, they have a concept called the CIA triad. That's actually one of the core aspects of information security. So CIA stands for confidentiality, integrity, and availability. I don't know why I stumbled there. Confidentiality, right? Are you even allowed to see this? You shouldn't see this unless you're allowed to see it, right? That's the confidentiality part, right? Integrity, is that data there? Right? Are you guaranteeing that data hasn't been manipulated, right? you can guarantee the integrity of that data, and that data is available to you, right? So that's the A. If the data is not available, then what use is it, right? Those three items are really the baseline around most of cybersecurity and what cybersecurity kind of focuses on in some form or fashion, right? So in your code, when you're developing your app, you want to make sure that your service is available. You build in some checks, right? Who here's heard of rate limits, right? Who here's ever had to deal with auto scaling, right? Load spikes, you don't want your server to get overloaded, right? So you have some auto scaling maybe set up, right? You want that to be available, right? You want to make sure that you're encrypting the communication. You're using HTTPS or something, right? This is an SSL cert, so that you can guarantee the integrity of that data being transferred. The confidentiality part, everybody I'm sure can already guess, right? You want a strong authentication layer. You want to not be able to bypass your authentication layer, right? And you don't want to cut corners when it comes to authentication, right? Or validating the state of authentication that somebody has, right? That gets into like the delivery and the deployments part, right? So you have your app, you've designed it to be, but you need it to be available. You need it resilient, right? But you deploy your code, and there you go. I run my pipeline, I commit, I push. The DevOps pipeline goes and pushes code. Cool, I'm good. Who here has heard of the SolarWinds breach? That was a pretty big one. A lot of people have probably heard of that one, right? The big issue with that one is they didn't really care about secure delivery, right? So does anybody actually know, like, does everybody know what happened, why that breach occurred in the first place? A lot of people don't know the details, right? What happened was somebody got into their environment and they got a hold of their code base, right? I don't remember if it was through a developer's workstation or whatever, but they managed to get access to the code base, right? And they found that they can have their version of the app pushed in the pipeline instead of the regular version of the app that the developers worked on. Let's go and inject this one class really quick during the pipeline, and there we go. And they just pushed to all their customers a compromised instance of their app, right? Some things that you can do to help protect the delivery and the deployment of your app, right? Code signing. Has anybody here heard of code signing? Right? Yeah. So basically, okay, when you're writing your code and you take this value that you want to reserve the integrity of the value, but you don't need the raw value, right? So like the best practice for passwords, if I'm going to write an app and I'm going to accept credentials and I'm going to store your password in my database, it is bad practice nowadays to encrypt that password and store it in the database because it can be decrypted. You can reverse engineer that. There are times when your app might need this, right? But if your app doesn't need it, which 9 times out of 10, you shouldn't ever need it, right? You're supposed to hash that password. You secure the algorithm and the salt, right? And you hash that value. You compare the hashes. Yes, they match. Okay, that's the right password, right? That same concept goes into signing your code, right? I have my code. It's 6,000 lines of code because I don't use object-oriented development or whatever, right? And you run it through a SHA-1 algorithm, and here's the hash, right? In your deployment pipeline, you check out your code base, you prep your server, you get everything, all your dependencies installed, and you check the hash of your app, right? You validate the checksum. Hey, I know this is exactly what was approved to be pushed. Let's go ahead and push it, right? That's a way. There's other ways, right? But that's a way to help secure the delivery, the deployment of your code, right? And part of that, right, you have to understand your dependencies. You have to plan for those dependencies. So we've got the pipeline. We're pushing our code. We have our checksum. That's all great. But my app is using this one library, this JavaScript library that makes it really easy to handle the AWS API or whatever, right? It gives an extra layer on top of the SDK that AWS offers, and I like it. It makes it easier. But it's supported by 2 people, and there hasn't been a commit in 3 years. And both of those GitHub accounts haven't had any activity in 3 years. Yeah, that's an issue for your app, right? Your app is going to fail to be able to accommodate new features gracefully. If there's a vulnerability with this little hole-in-the-wall library that's not widely used, it's most likely not going to be identified that it has vulnerabilities because it's not widely used. And there you go. Now your app has some vulnerabilities that you weren't even aware of due to a dependency, right? So it's really good to understand and plan your dependencies. Based on your app, that might not be an issue, right? But a lot of times, if you want your app to last, 5, 10, 20, 30 years, that's definitely something you have to think about. How many people have had to not update the OS because their app was dependent on a library that would only run on the older OS version, right? So it cascades. It snowballs really bad. It's a lot more important than a lot of people think, right? And who here's heard of an SBOM before? A software build of materials. That's basically your dependency list. They created a fancy word for your list of dependencies, and they called it an SBOM. We were creating these before there was a term for them. But then maintainability, right? That kind of gets into that maintainability factor, right? So I have my app. I make sure that I'm designing it to be secure. It's got rock solid authentication. It's resilient. My deployment's good. I made sure that I'm doing checksums on my apps, and then I make sure my dependencies are rock solid. I have a good process to vet my dependencies to make sure that I'm always updating versions for dependencies in a standard life cycle. Now my app's in production, cool. The delivery process is there, but you have to maintain the running production instance of your app, right? And now this is where a lot of the security tools nowadays focus, right? Part of your app needs to go back to the design part, right? Part of the app needs to be able to facilitate it being maintained properly. If you didn't design proper logging in your app, you're not going to have the information needed to properly maintain it. You have no visibility into the runtime of your app so that you can identify when a nuance occurs or an edge case happens or something just off the wall is going on and you're not sure why it's doing it. You're never even going to know. All you're going to see is, wow, resources are spiking up and it's auto-scaling. Right? So you really want to make sure you're designing maintainability of your app into the code, right? So all this kind of goes full circle, right? That's these are the core concepts of application security. You could go sit through a 6-hour course on application security, and basically they're going to give you a slightly deeper version of what I just provided for this slide. I had to do one, a 6-hour course, and that's basically what it was. And that's why, this is part of the reason why I think developers need to be more involved with the planning and the documentation of their app so that when they hand over an app to the team maintaining the production instance, right, it can be maintained properly, right? The developer needs to help with that maintainability, right? So there's this gap, right? This gap between developers and the security teams, right? So where does that really start, right? There's so many things involved with just the way that the industry's grown, and probably partially due to the immense amount of money in bolt-on security tools. But there's a lot of factors, right, that kind of aid in this rift between cybersecurity and developers, right? So cybersecurity and software development teams, they're very isolated, right? How many people here are developers that have never had to interact with their security team? Oh, okay, that's good. I actually wasn't expecting that. That's kind of rare, right? So how many developers here have actually been asked by your security team your opinion or insight on how to better secure your app? Oh, a couple of people, but most people here, that's an abnormality. That doesn't usually occur. Usually what happens is a cybersecurity guy comes back and goes, your dependency's got a vulnerability, you need to fix it. You failed a SAST scan, you need to fix it. And that's about all that the security guys care, right? They don't want the feedback. How do we put our tools that we bolted on your app more secure? No. You just need to fix this part so that our tools that we bolted on can work better, right? And also, this is probably one of the biggest ones that I've seen, right? Is it's not budgeted or planned for. Oh, the business did not include that in the business requirements doc. Okay, well that's going above and beyond. We didn't plan for that. That's going to have to be a phase 2. That's going to cost too much to do that now. We're just going to do that later. Later usually doesn't happen unless a developer goes, nah, screw that. I'm going to wedge this in because I can't live with myself knowing that I created this and I didn't get to make sure it was secure, right? I've done that so many times. Some of the people I've worked here in this room, I know have done that a couple times, right? But it's not accommodated for in the planning, right? They don't plan for it to be secure. They plan for it to perform this functionality. Right? And again, to go back to, it's traditionally network oriented, right? They think, oh, well, we're just going to make sure that only port 443 can talk to the app and it's going to be secure. That doesn't really work nowadays. We can get into the more detail around that a little bit later, right? But the landscape has changed a bit, right? And then again, all the bolt-on tools, right? It provides a false sense of security because some business guy that doesn't understand the app, he doesn't understand technology to the extent that the developers do. We bolt on this app and now it's secure because I just paid $3 million and this guy said it was going to make it secure. So that's a lot of money. It better make it secure, right? Big false sense of security for the upper management of the business. And there's a bit of a communication rift, right? Again, this big rift between developers and all the rest of the org that really manage the long-term security of a product or a company, right? So let's see. I lost my spot here. All right. Yeah, but so to go back to those first acronyms thing I mentioned, right? So here's a couple of acronyms. Here's some of the core terms that you're going to hear when you get into cybersecurity in any vertical of cybersecurity, right? CVEs, CVSs, and CWEs. Who here knows what these are? Who's had to work with these before? I'm sure Adam has. All right. So I'm going to work backwards here, actually. So a CWE, right, is a weakness enumeration. This is a classification or a category for a type of vulnerability, right? It could be an injection attack, right? A CWE for injection, right? It's a weakness. It is a weakness in your application for a SQL injection. It could be a weakness for buffer overflow, direct file reference. There's so many different specific enumerations of a particular weakness in an app, right? So it's like a category. So say you develop your app and you're just taking the raw input from a post request on a web page and you're taking that input and putting it directly into a database query, right? So now you're susceptible to a SQL injection attack, right? So that would be the CWE, right? But what happens there, right, is you deploy your app, now bad guy goes, oh, what? I can inject in here. I'm doing all this fun stuff. And now it becomes prominent that, hey, this app is vulnerable. Like there's a security issue with this app, right? So a CVE will be generated by a certified authority, right? Like Microsoft or somebody that's certified to do so, because Microsoft is like the number one CVE producer. So what this does is this is a very specific number for your vulnerability in your app. It is a unique identifier for that specific vulnerability, right? And so a CVE will always track back to this vendor's app and it will be mapped to a CWE so that you can understand what was the weakness And it'll often give a lot of information more about the vulnerability, whether it's been publicly exploited or just proof of concept exploited, a lot of things like that, right? It will also have a score associated with it, a CVSS, a common vulnerability score. So right now the latest is 3.0, or did they move to 4.0 yet? I don't remember. I don't think they moved to 4 yet. But basically, it's a 1 through 10 rating. 10 is, hey, this is a critical vulnerability. You should either not use this app or patch the app, depending on which side of the table you're sitting on in regard to that app, right? It's a easy business view of how impactful a vulnerability is going to potentially be. Now, with a grain of salt, everything with the score system is with a grain of salt, because your app can be using this library. This library has a CVE and it's scored a 9.8, and you're like, oh my gosh. And then you come to find out that you're not using the component of that app that is actually vulnerable. So that's a false positive, right? But your bolt-on security tool doesn't know that. Your bolt-on security tool is like, oh no, you got 9.8s, you failed. Your developers need to fix this. And then they're like, well, there is no other dependency that I can move to. What do I do, right? Now you've got developers chasing their tail for a phantom that is not even going to impact your system because it's a false positive, right? So again, pointing back to the developer's interaction and involvement with the security team and the overall IT teams to help make sure something is secure, right? So that you're not chasing tails, and the things that are actually pertinent you're focused on, right? And another thing, right, your app can be using some library or something that has a CVE, and the score is like a 4, and it's not too bad, right? But the way that your app is using this happens to make it more prominent and easily hit, right? And now all of a sudden, for your app's perspective, because this is a dependency of your app, this isn't your app, that maybe increases to an 8 or a 7. And you're like, okay, well, it says it's a 4, but trust me, we need to take care of this before some bad guy finds it and we're going to end up on the news, right? Which you don't want, right? So even more acronyms. So lots of acronyms here. So these are all either tools or concepts that are considered cybersecurity related in some form or fashion, right? So on the left here, we have a bunch of cybersecurity tools, right? Moving on to there, it kind of bleeds into, again, code signing, that concept, right? And SBOM, we talked about that, right? Goes into threat modeling and some other concepts, right? So let's start over here, like a SIEM tool. Does anybody here know what a SIEM tool is? Has anybody here heard of a SIEM tool? Yeah? Splunk, Elasticsearch, right? Basically, it's a log ingestion platform that allows you to dynamically query the logs and configure alerts based on results of queries that would automatically run on ingestion. I know developers that have created this internally because there was no Splunk at the time or Elasticsearch at the time, right? And now it's a whole tool, and Splunk is a very lucrative tool. They overcharge for data really bad, but it's a very valuable tool, right? Again, going back to the maintainability of your app. If your app is logging and your system is logging and you're ingesting those logs, you can identify normal behavior patterns, anomalous behavior patterns, right? The better your app does at logging things, the more capabilities you have in your SIEM, right? And then a lot of security tools will hook up a SOAR platform to their SIEM tool, right? It's a security orchestration, automation, and response tool. Basically, it's a tool with a GUI that runs predefined scripts to do things based on what happens in these logs, right? So your log comes in and it says, hey, you deployed an AWS asset and there's no tag for this AWS asset. And you can have your SOAR go, okay, automatically go apply said tag to AWS asset, right? Or, hey, we deployed this and we see that this system got an update and there's a network file share that has everyone access to it, but that file share contains sensitive data. Excuse me. You can have your SOAR automatically go in and change the permissions on that file share to a predetermined safe configuration, right? It's an automation tool, right? Many of us have done exactly what this does in just a handful of standalone scripts as a minor case for it, right? But the companies will charge a lot of money for licenses for a SOAR tool, which, again, it's just automating basic scripts. And all you're doing in that tool is creating scripts, either through raw code or little GUI interfaces, right? And then we have the suite here, which actually extends beyond that, right? But we have ASPM, CSPM, there's a DSPM now, there's all these SPM, security posture management tools that are focused on this particular area, right? And then you get like a CNAP, which is a cloud-native application protection platform, which kind of does the same thing as both of these, and usually does this too, but only for cloud. So one of these and one of these kind of does the same thing as this, but to a broader audience, right? So a cloud security posture management system, right? It's basically exactly what it sounds like. It's looking at all your cloud assets, and then it's saying, based on AWS best practices, GCP best practices, the NIST framework, or whatever compliance framework that you have to abide by that you have configured, right? It'll look and say, hey, you're not compliant with this, right? You failed this check because passwords aren't automatically rotated, or your password complexity is not required to be at least this, right? It's going to be too easy to brute force, so you're really not compliant with this or this configuration. Now, usually you can set those policies as you want, right? A lot of people don't have to deal with like federal regulations, but a lot of people do, right? So these tools, one thing that they do is that stuff's all baked in. It has alignment for all these different frameworks. All you really have to do is throw it in there, point it at your thing, it'll ingest and tell you. Now the thing about that is, cloud tools usually have native built-in stuff that'll tell you that. AWS Audit Manager, Security Hub, right? Like you'll be able to get the same information, but it's not gonna be through a single pane of glass, right? So what are we paying for with this tool that wouldn't be available if developers were really just more tightly in tune and responsible for more than just developing an app in the cloud, but for scripting against the cloud native services that are already there, right? Probably wouldn't even need this, right? But a lot of companies don't have the bandwidth for that level of developer overhead, right? So that's the give and take there, right? An application security posture management, it's basically the same thing as that, but for applications instead of for cloud assets, right? It just tells you, hey, this application is doing this or that it shouldn't be. This application is, it's not compliant with this mandate because it's storing all this information that should be sensitive in plain text. It's not encrypted in any way or whatever, right? So there's these tools, right? And then WAF, right? So a lot of developers have heard of a WAF tool, especially web developers. Anybody here had to like work with a WAF tool before? Web application firewall, right? So if you developed a web app, right, the majority of what you can do in a WAF tool are things that you're likely going to do in your web server or application anyways, or should do, I would argue, right? There are benefits though, right? So I can know in my app that the only ports that should be used are port 443 because I'm accepting HTTPS traffic, right? I have an SSL cert applied and it's a web app. It uses port 443, that's a standard port. And you know, I have a database on that same server. It's a MySQL database, and it's called by some other systems, some other apps. So my system is going to also need to be listening on port 3306, right? But those are the only ports that are needed, right? But then you get into the WAF layer where they take your app, right? Or they take this WAF, they stick it in front of your app. All the traffic goes through this WAF before it goes to your app. Now, it's great because it offloads all of the traffic from your app. It pre-filters it. You don't even have to worry about resource contention for a bunch of just bad traffic, right? Because it's going to help protect against it. But that WAF has to be configured to that very specific detail that your app is for it to be most effective. Usually that never happens, right? Usually there's a bunch of basic rules that say, look for semicolon or 1 = 1 in a query string. Or, look for non-UTF-8 characters in a post body. Or, it'll look for various patterns or indicators of compromise of some sort to say, hey, there is somebody compromised this input field or this web app. They're trying to do something silly, right? That's actually multifaceted. I'll talk about that again later. But yeah, so the WAF is basically pattern matching against various things and blocking traffic, right? You can do a lot of cool things with a WAF that says, hey, only accept traffic from this source, right? If you only accept traffic from very specific customers, you can limit it to only these IPs, right? So there are benefits to it, right? And so I don't want to go away I don't want to go away from the talk with people thinking that you don't need all these security tools. Developers just make things secure. There's a lot of benefit to these. However, the value of a lot of these tools is much less than it could be if developers were more involved with aiding in the configuration and the tuning and providing the detail, right? So SAST and DAST are scanning concepts, right? So who here knows what a SAST scan is? SAST scan? Okay, so that's a static code scan. What it does is it scans your code. Basically, it goes through your logical paths of your code, and it identifies nuances that would indicate a CWE, right? If we go back to that other slide. So it will take your app and it'll know, okay, you have a PHP app, right? And you have your router file, you have traffic coming in, it hits this controller. Here's the first piece of functional logic that happens when a request comes in from the internet, right? And it'll take and it'll say, okay, you have this request variable. All of this things happens with request variable. It goes through all the way to where it returns a response, right? And it'll go, oh, you validated your input. You sanitized, you normalized your data from the input, you did all of that, but later on in the code, you didn't reference that variable that you cleansed and passed through. You went and pulled the direct request object instead, and then you referenced that in this piece of logic. That's a vulnerability. A developer might not realize that, right? If they're not going through that full code path, things get missed, right? Especially in large, complex code bases. So a SAST scan is really good at helping, double check you for little things like that you might have missed, right? So, but that's a SAST scan, it's a static scan. It's looking at a static piece of code and it's just traversing the logical paths, right? It's completely different than a DAST scan, which is basically the opposite, right? Okay, I scanned your code and mapped out your logic paths. It should be good. These aren't going to test everything, right? They're not going to identify that you mishandled a JSON web token, right? They're not going to be able to get that complex, but they're still very good, right? So then you have a DAST scan, and that's basically like an automated pen tester, right? It just goes through a whole suite of tests, and it says, I'm going to try to put semicolon or 1 = 1 in a query string and see if that works. I'm going to go and try to add some raw bytecode into a request header and see if that works, right? I'm going to see if I can, go to the URL ///////env. Did I get their environment variables returned, right? It could be a web server misconfig. Believe it or not, that stupid little thing is more prominent than it really should be, especially with IIS. but yeah, so a DAST scan is basically like an automated little pen tester tool that you can run, right? And then there's RASP tools. Well, these are really cool. I really like the concept of these. The overhead on an app is arguable. Some people say that there's a lot of overhead. I've heard others say that there's not. I'll be honest, I haven't really got to intimately work with a lot of RASP tools. Anybody here really worked with RASP tools very much? Any good experience? Okay. Well, if you do, let me know. I'd like to get your feedback. But from a core concept, right, what this is basically a dependency in your app, right? This runs as part of your app or basically within the system of your app, right? And it monitors the various paths of logic that your app does, right? So say you have a thing that it takes a request, sometimes it calls a database, sometimes it calls a Redis cache, it does its thing, it returns a response. This function usually calls this function, but sometimes it calls this function, sometimes it's recursive up to 3 times, and that's it. It'll map out normality of your logic flows and your code. And then it'll go, whoa! All of a sudden, this request came into this same endpoint, and it's referencing a direct reference to a flat file on the system that it shouldn't. It's never done that before. This will have the ability to kill the process and let your app gracefully keep flowing. Mid-attack, stop it from happening. That's the concept, right? Pretty cool concept. How well it works, again, I haven't really tested it, but that is one of the newer AppSec tools in the space that usually most companies don't opt to spend that much money. They usually say, okay, we're scanning the code, we're testing the code, we're signing the code, right? We know it's delivered right. We got to trust our developers. We have good logging, and we have a SIEM tool. I don't want to pay the extra money for that, or whatever, right? That's what I tend to run into, which is why I haven't really got to play with them much. But yeah. And then code signing, right? We talked about code signing a little bit. In case you're curious, OpenSSL and Microsoft Sign Tool are both free. You can use both of those tools for free for code signing if you're trying to really be proactive about secure deployments and stuff. You should give those a check, right? And so indicators of compromise. Oh, go ahead. Do you have something?
Sorry, I have a quick question.
Sure.
You talked about open source tools for code signing, but I'm quite surprised in the cybersecurity space there's not more open source tools for alternatives to things such as SentinelOne and these sorts of agents that run on machines to detect certain things. Is it just that it's extremely complicated to build these sorts of things? Or why isn't there more like open source alternatives? Because obviously the cost for some of this isn't doable for small businesses, right? So I'm curious what your thoughts are on that.
I wouldn't want an open source security tool. As a business owner, as an engineering leader, the last thing I want is all the code for how they're analyzing our applications out there and available. So that's just like a personal preference of mine.
So there are a good amount of free tools, right? However, you're right. You're not going to get the coverage, right? And there's going to be a big gap with the free tools when you get to when you move on to the paid tools, right? So regarding the open source things, right? Believe it or not, a lot of these big companies take open source, they put their own little layer on top of it, and then they resell it for millions of dollars. So a lot of it is actually open source in the core because it's cheaper to deliver that way.
Yeah, in working place, they had this really bad workflow experience. And so they're like, oh, everything must be open source. So they actually did build everything. But the amount of energy and work to build up these tools to work as they did work as well as those, right? They also got kind of jacked by New Relic one time too. So they did build it all internally. But again, there's this like core group of developers that are very specialized, that are building all these tools, and it takes time to come up with new features as things are moving and going along. Oh, here's this new feature, but now I've got to go change these 6 apps that go use this thing. So I think a lot of the times it's just, yes, they cost a lot of money, but it may not be cheaper than doing it yourself, but there's a lot less risk in the, I'm not going to keep up.
Yeah.
It's like running your own GitLab instance self-hosted versus just using GitLab and you don't have to maintain it sort of thing, right?
Well, yeah, kind of, because so the company I work at, for instance, right, their concept is avoid open source, right? And if somebody is just throwing their layer, a small layer on top of open source and reselling it, that's fine. They're fine with that. The reason is because now there's a contract with that person that says they're responsible within certain guidelines for certain things, right? So new thing comes out, there's a new 0-day vulnerability with Windows, everything needs patched. That guy needs to get on it. My dev team doesn't have to do nothing, except for wait for them to come out and tell me to update your thing, right? Or for them to push an update. When it comes to a lot of the, like you were talking about, like Sentinel-1, right? The what they call endpoint protection tools, right? Like CrowdStrike. Everybody knows of CrowdStrike probably after last year. Everybody sort of CrowdStrike, I'm guessing? So CrowdStrike is a non-consumer grade endpoint protection platform. They will not sell to consumer. They only sell to corporations. Part of that, from an article I read, which it was from someone at CrowdStrike, so I have to believe it at least to some extent. Part of that, I guess, is if the average Joe is running their platform, then they can find ways to bypass it and manipulate it, even though it's not open source. So they only sell to corporations and companies that have a vetted interest in only being responsible with their use of it, right? So that's, I guess, a factor. I can't answer for a whole industry, but it's, like Adam said, it's very costly for the open source ones to maintain it. If you have a group of dedicated people that are really there to keep maintaining it, you'll have something open source, but is it ever going to be the same quality as this tool that you have 1,000 customers paying millions of dollars and you have a team of 40 developers that are every day working on it, right? You're not going to get quite as good a quality, right? So, I'll give them that. So I don't know if that answered your question, a little long runaround, but yeah. So speaking of endpoint protection tools, right? As we were talking about indicators of compromise, right? So a lot of what those endpoint protection tools do is they look for indicators of compromise, right? Oh, there was a ransomware on this company, right? And they found all these files left over by this hacker group that ransomwared them. We're going to take all these files. We're going to find the checksum. We're going to hash these files. We have the hash value for this file, and then we're going to publish it as a public IOC, right? And then everybody consumes this and feeds it into their security tools and says, hey, if you see a file with this hash, block it. Right? And so your CrowdStrike and your Sentinel-1 and everything, see, you downloaded a file. Hey, that matched the hash, block. Right? That was an indicator of compromise, block. An indicator of compromise could be anything. It could be an IP address. It could be a URL. It could be a file hash. Right? It could be a very specific PowerShell command. Right? It's a vague concept that is just something I'm watching for that says, red flag, something bad's probably happening. Right? And that's how most of those endpoint protection tools actually work, is they're just mapped to a bunch of indicators of compromise, right? Yeah, there's other bells and whistles, and they collect a bunch of metadata and other things, but that's basically the core concept of a lot of these. It's purely reactive, again, right? A lot of the stuff you'll notice when we're talking about all the security tools in the environment and the ecosystem for security, it's almost all reactive, right? Developers are the only part that is proactive in securing your product, right? We talked about all of that stuff a little bit for the software bill of materials. Threat modeling, I'm sure everybody here hopefully has at least heard the term threat modeling before, maybe. Threat modeling, I'll tell you one thing, is in my experience, there's a, what's that term, a level of diminishing return? You can threat model, right? You can mentally map out in your head, okay, these are the different things that could happen, and this is what the impact would be if it happened, right? And arguably, yes, it is a good idea to get a lot of that on paper to some extent. But some companies require these full detailed threat models of every single potential threat and all the impacts and everything, and that, to me, that's a little overkill because it's very opinionated, right? What is the impact, right? Okay, if you're going to score something from 1 to 10 as far as how impactful it is, there's something that everybody's going to agree on, right? If the impact is you just gained root access to a server, I'm sure everybody would agree. That's probably bad, right? But then there are other things that some people might disagree as far as how impactful that is, right? Especially when the application or the project or the request is stemming from a business unit like a marketing team. They are not going to agree with the potential impact that an IT person is when you say, if someone does this, this could happen. They're going to go, I don't care. So do some mental threat modeling as a developer, right? Think about what could happen. How can someone misuse it? How do I at least put some guardrails in place to make sure that my app, for the most part, is covering edge cases, and you're already basically doing a basic level of threat modeling by just thinking through those processes, right? And then security frameworks are a big part of the bridge, I guess, between cybersecurity and compliance teams, right? How many people have had to deal with auditors of any sort? Yeah, they're not fun. They're like, oh, well, do you align with NIST CSF? Do you align with CIS? Right? Are you ISO 27001 compliant? Do you follow NIST 800-53? Yeah, trust me, you don't. It's not fun remembering these stupid things. These security frameworks are a good baseline for reference, but they are the business face for, I guess, attributing that this app is secure, right? Oh, I align with NIST. I comply. I got this auditor that says I'm compliant with NIST framework, so you know I'm secure. What was that?
It's about reputation.
Yeah, it's more of a reputation thing, right? No, I have a lot of opinions as far as the facade of correlation between a security framework compliance and actually being secure. I'll take a PCI for an example. How many people go, oh, PCI, that's around to make sure that my card is safe when I use it, right? To make sure that I can pay for things securely, right? Did you know that even the current PCI, if I decide I don't align with half of the stuff in PCI, all I have to do is provide business justification for why I don't comply and an action plan. Whether I follow through with that action plan doesn't matter. As long as I have an action plan and a business justification and I say, I can't do this now, they go, oh, okay, box checked. That could be, oh, I don't have enough money to make it secure. They go, oh, okay. That is bad, but that's unfortunately the reality of a lot of security audits. So I'm not even going to keep going into that because you could tell I have strong feelings around a lot of these audit frameworks and stuff, right?
I think the main problem there is like those things are more like a snapshot, like at a given point of that application instead of like a continuous process of security. You know what I'm saying? So when they got that NIST certificate. At that point it was, but then like a week later someone put a new patch that has a vulnerability, then now you're screwed.
Yeah. Well, a lot of these frameworks, right, they try to accommodate for stuff like that, right? So they say like, okay, you have a documented process to ensure all your dependencies are updated and patched, right? Okay, that sounds good. But yeah, I checked the box, says I have a process. Even if that process is when somebody reports a vulnerability, try to fix it. It could be not monitoring, not being proactive at all. Nope, you have a plan, it's documented, check, right? So again, these frameworks say they have line items for that kind of things, but it doesn't necessarily mean it is, right? So just because you see a stamp on something, don't necessarily take that stamp as word, right? And I think I've burnt a good amount of time on this slide a little bit, but Who here knows why infrastructure as code is considered a security a security item, an asset to security? Go ahead.
Because you know what your infrastructure looks like, you can review the changes, and you can determine, approve things that are going out and what they're going to be.
Exactly, yes. So you have not only the record of what was deployed, but also the record of what was approved, and the history of what has been deployed and approved, all built into the code itself that is being used to deploy, right? So as a security guy, when I say, hey, we approved this code, and we approved this service, and we approved all of this stuff as what was going to go out, I need you to prove to me that that's what went out. I don't want to have to go digging through all your user stories and your commit history and every different merge request that culminated from that last master branch into this master branch. And like, I don't want to have to go dig through all of that. That is ridiculous, right? But when it comes to like the infrastructure side of things, right, I have to do something similar. Oh, it's supposed to be on this server. Is it getting patched? Is it doing this? We can do a bunch of checks. We can use our SIM tool maybe to help us look into some stuff, right? We can automate some scripts with our SOAR tool to pull in a bunch of data to validate compliance or whatever. Or I could just reference an IAC history. Makes it so much easier, right? But yeah, so this is only a small subset. The acronyms just go on forever. There's acronyms that are just like other acronyms. Yeah, if you don't like acronyms, don't dive into information security too much. So besides that, right, what are some resources that you might want to dig into, right? Like where would you start? If you're a developer and I want to know more about cybersecurity or just IT security in general, where would I start, right? NIST is a great place to start. CISA is a great place to start. So NIST, right? They're very popular for their compliance framework, like I had mentioned earlier, right? They have a lot of federal mandates will say you have to comply with NIST Cloud Security Framework or NIST Cybersecurity Framework version 2.0. Or I don't know. I'm getting them confused. The names confused now all the time. But they come up with a lot of different frameworks. They actually recently released an AI risk management framework, right? Which is pretty cool. NIST, the National Institute of Standards and Technology, they actually go well beyond just IT security and stuff. They do all kinds of stuff, right? I read a thing the other day that they were trying to innovate fire prevention and fire dispersion systems, right? Because the whole Tesla battery fires are so hot, they need to find new ways to be able to fight fires because of Tesla battery fires. That's literally the core reason why they started that project, right? But they do a lot of good work. Outside of that, it's worth checking out NIST just in general, right? CISA is the United States Cybersecurity and Infrastructure Security Agency. This is the United States standard reference for security. If you're wondering how US does it as opposed to EU or Australia or wherever else, right? That's going to be your resource, right? Yeah. And some more resources, right? So MITRE, it's a not-for-profit corporation that has earned, what was it, $13 million in profit last year alone or something like that, like millions of dollars in profit for a not-for-profit company, yeah. But they do some cool stuff, right? So they have a lot of research and development centers that are funded by the government, so they work really closely with CISA. They're most notably, they're most recognized for the MITRE attack framework, ATT &CK. Some of you might have heard that before. The MITRE attack framework is basically, it's basically a way to map out the stage of an attacker given a certain engagement, right? And let me explain a little bit, right? So attack actually stands for, I had to pull it up really quick because I forgot to put it in my notes, adversarial tactics, techniques, and common knowledge, right? So what it really does, right, is it maps out the stages of a hacker if they're infiltrating your system, right? So it'll start out with initial access, right? They're gaining some access, right? They're executing some scripts. They're doing a little reconnaissance, right? They gain persistence in the environment. Then they end up finding ways to get around your endpoint protection, right? They figure out what you're running so that they know how to get around it so they're not detected, right? And then they, try to find their way to escalate access, find some other credentials that they can that they can use, or do an LSAS dump or whatever, reuse a Kerberos token, one of many ways, right? And use that to gain more privilege or a better foothold in the environment, right? So they could get to the big money items, right? So it's a very valuable thing if you're not really into the security stuff and you're interested in how they categorize just the adversary side of things. It's definitely a good reference, right? And then OWASP, yay OWASP! OWASP is great, right? Everybody loves OWASP. So, OWASP is the Open Web Application Security Project. It is a free open source community. All of us just basically volunteer time and efforts for the greater community. It's all focused on application security. What's funny is it's called the Web Application Security Project, but really it does go a lot beyond web apps, right? I can't ever talk about OWASP in any talk without bringing up the cheat sheet. If you're not familiar with OWASP, you should check it out. Most people hear of the OWASP top 10. They don't realize that there's actually multiple top 10s. Like the web top 10 is like, oh, there's injection and whatever, right? I don't know if you've heard of the top 10, but that's probably what you're most likely familiar with. They have an IoT top 10. They have a mobile top 10. They even have an ML top 10 now, right? I think there's one or two others that are in there, right? So they release those, every 4 years to give you a landscape of what other companies in the industry have publicly reported to them, right? So that they can gauge and come up with these top 10s. It's not just some arbitrary list where some guy is like, I think this is probably more prominent. No, it's all from records from actual breaches and stuff, right? And then go back to the cheat sheet. The cheat sheet is awesome. I find stuff all the time in there. Every time I go in there, I find something, like I give myself one task. I say, I'm not gonna leave the cheat sheet until I read something new. It's been years. Every single time, there is something new to learn. That thing always grows. If you wanna know specifically for PHP, how to do PHP-specific securing your PHP app or whatever, there's all kinds of stuff specific to the PHP. JSON web tokens, like you name a category and it's probably got something on it in there, right? It's definitely worth checking out. It's definitely a good resource, and not just because I'm the chapter leader for OWASP. All right, so here's another core concept for cybersecurity traditionally, right? There's a lot of acronyms, right? But then there's, oh man, I'm forgetting the term now. Oh my gosh. So, please do not throw sausage pizza away. That's how I remember the OSI model. Please do not throw sausage pizza away. If you go for any job interview in IT security, they're going to ask you about the CIA triad, and they're going to ask you about the OSI model. They're going to, guaranteed. If you notice, network communication breakdown. This is 100% specific to networking. You get an AppSec architect job role. They asked me about this. A third of my interview was making sure I understand the OSI model, when this is the purview in which I was being hired for. So, kind of highlights that fact that networking is traditionally the avenue in there, but there's a lot of aspects of the industry, the cybersecurity industry in general, that is still trying to catch up with, again, modern technology, right? I'm not even going to go into all the details and each of the layers, right? But yeah, basically, if you're interested in networking, This explains from the physical layer, like the different layers of the network that gets all the way up to your application. Did you have a question?
Yeah, what was the first thing you said that you get, like, is a big part of the interview besides this?
The OSI, or the CIA triad. So confidentiality, integrity, and availability, right? So that CIA triad, that's a core concept of information security. Most likely they're going to ask you about that. The OSI model, most likely they're going to ask you about that. These are two very core concepts. When you deal with any network security person, or anybody that's a topic of discussion that involves network security, they're going to say, oh, well, we have a layer 7 firewall, and it's protecting against all this stuff because it's a layer 7 firewall, right? You have to know what that means. Does anybody here know what a layer 7 firewall is? Yeah? Actually, what's funny is kind of. A WAF is like a decoupled only layer 7 firewall, basically. So what a layer 7 firewall is a traditional firewall says you're allowed to communicate over TCP on this port from here to here, right? And you can very specifically tell the firewall that traffic is allowed to go here and here, and it's not allowed to go here or here, right? What a layer 7 firewall does is it actually does an inspection of the packet and says, oh, this is on port 443, and it has a header and body in the request, and it's like, oh, this must be web traffic, right? Oh, but web traffic could be on 80 or 443, so, oh, this is SSL traffic. So it'll classify your traffic as web and SSL, right? And so if you're saying, hey, my app only accepts web SSL traffic on port 443, right? That's going to help, right? So your layer 7 firewall is going to help make sure nobody's trying to, like, I'm going to ping the server and see if it responds. I'm going to see if I can SSH directly into the server. It's not even going to let it. It's just going to kick it out, even if you don't have a WAF, right? So arguably, from a network team's perspective, right? Arguably, we don't need a WAF. We have a layer 7 firewall. They're not the same. They're not the same. But yeah, so let's see. Yeah, so when you have a modern web app, right? You have a layer 7 firewall, you have a WAF, you have all these protections in place, right? An example of how a developer is going to do better at securing this, right? Well, is the layer 7 firewall or the WAF going to understand that you opened a WebSocket connection over port 443? Maybe, but usually not. Is your app supposed to have a WebSocket connection? I don't know. The developer will know, right? So, again, that goes back into how is your app supposed to be used? These things are arbitrarily categorizing things and bolting on security. But if the developer was more involved with the whole rest of that aspect, there's a greater potential for a more secure product, right? Right now, if I make a web request to so say I'm on a website and I make a forum post, and that forum post goes to your web app, right? And then I go into the code, I inspect element because I'm a little hacker, and I go in there and I add an input field, and I take that input field and I put a special value, and then I submit it, and I'm like, hee hee hee. None of these tools are going to be able to catch that. Only your app is going to know that. If you are doing a blind mapping of a request object of the request, or the request object into some other object in your code, and you're blindly mapping these fields, there is a lot of potential negative impact that could happen, right? Developers going to need to make sure that they're validating, they're sanitizing and normalizing that data. They're not blindly mapping inputs, right? That they're taking that normalized, validated piece of data and using that in their logic, right? So again, it's getting away from that reactive approach and more towards developer-centric, like let the developers make sure the app's secure kind of thing, right? That's the concept I'm trying to go with here tonight. Right. So to continue on, a little bit about the networking side of things, right? Most developers have had to connect to a database or a Redis cache or another API at some point, right? When you do that, you have to configure, oh, well, it's MySQL, it's port this, right? It's SQL Server, it's a different port, right? So who knows what port 80 is for? HTTP. What about 443? HTTPS, right? Pretty standard. The only difference is you have an SSL handshake, right? So you can encrypt that traffic so that that request isn't easily readable by anybody else on that network, right? So now you have that traffic's encrypted in the network. Now I can submit my username and password and not worry that I used that same password on my bank and now everybody at Starbucks is gonna, know my password. You don't have to worry about that because you have HTTPS, right? So 3306, who knows that one? MySQL, right? What about 1433? SQL Server, yeah, right? 53? DNS, right? So most developers quickly learn the ports that their app needs. So if we need to protect network traffic on a firewall, and the traditional mindset that I have seen from network engineers at multiple companies is, oh, something's not working. There's traffic being blocked on the firewall. We need to allow that traffic because the app's not working. I can't tell you how many times I've heard that. I'm like, no, I guarantee you the app is not breaking because SNMP traffic is not going to the app. I guarantee that's not breaking the app, right? It shouldn't even have SNMP traffic going to it, right? What about TCP and UDP? Who knows the difference between TCP and UDP? Yeah? What's the difference?
TCP waits for a response and UDP is a fire and forget.
Yes, UDP is a broadcast. It's just saying, hey, you guys, there's this thing. Hopefully you were listening, right? TCP is, hey, I'm me. Are you you? Yeah, you're you. I'm me. I have a message. Did you get the message? Yeah, you got the message. Okay, cool, right? You can guarantee delivery, right? There's a lot more overhead. Each has its use cases. But the developer's going to know if their app is using one or the other. Instead of the networking team going, oh, there's something blocked on the firewall, we better allow it. Not always, but right? Right, so.
Mr. SD server work. I can't connect Mr. SD server. I'm not getting used to that.
Yeah.
My favorite story was SSH port getting blocked 22, and I just updated it to 2222, and then got it.
And that's it, right? So, okay, going back to WAF, right? That's a very common thing. You'll find these tools, right? It's a WAF tool. That's what it's meant to do, is protect traffic into your app. That's all it is. It's a proxy with a filter on it. That's all it does. And they goes, well, we don't support port 22. And you're like, so if I have an SFTP server and you don't protect SFTP traffic then? No, because that uses port 22. So I have to use a non-standard port, which comes with its own security issues, by the way. When you try to security by obscurity or whatever, it usually doesn't work, especially when things like Nmap will just run against ports and be like, this port is open. Well, let's see what service is on that port. Boom. They have automation tools that'll go and tell you what port 2222 is doing in a heartbeat, right? So it's really not making it more secure, right? It's getting around the firewall guys going, no, we're secure because we blocked port 22, So
Usually when they don't support those ports, it's because they need it themselves to access the app.
Exactly, and that tells you that. So the tool our company uses for WAF protection, right, does not support port 22. Every other port it'll support, but port 22, right? So that leaves with two questions. Why are you remotely accessing any assets directly from the internet through SSH in a company that does that type of a product, that provides that type of a product? That's an engine. That's an architectural gap, right? Like you missed something in your design there. You might need to go back to the drawing board and clean some stuff up, right? You're limiting your customers. It's going to be very obvious, right? And I guarantee you that port 22 is getting hammered all the time by every scanner that's out there, trying to see what they can find. But yeah. So between networking, right? Like a developer is going to need to understand the networking, right? All the logic of the app. They're going to understand what the data is supposed to do in this app. If I get a request, they're going to know that this should be a name. This shouldn't have percents and ampersands and semicolons in it. It's a user's name, right? The developer is going to know that. Developers often have to quickly become accustomed to encryption, right? They're going to have to understand, again, what's the difference between encrypting something and hashing something, right? It's an intrinsic part of being a developer. When you really grow as a developer and you really get into the depths of everything, encryption is something that you almost can't get away from, right? In some way or another. Right? There's just so much of it. All of these things that your app needs to be secure, developers know more of than anybody else in the environment, right? And then that kind of brings us to the proliferation of cloud, right? So who here has a favorite cloud platform that they like to use? Right? Who here likes AWS? Who here likes GCP? Alibaba? No. So there's multiple cloud platforms, Oracle, Azure, there's a bunch, right? Developers flourished. When cloud became a new thing, developers jumped in and they flourished. It was a playground for developers, right? Dev and DevOps are what made cloud grow to be what it is, right? What's the word I'm looking for here? The potential that is the cloud was only realized by developers or the engineers, right? Going back to those earlier quotes, right? The engineers found all these cool ways to use these virtual technologies, right? We were playing with containers and trying to make our systems more robust and to make that deployment time faster because you don't want a 2-hour outage to deploy to prod because you have that prod deployment on a Friday afternoon because the business needs it by the weekend, and that sucks. Now you have containers, right? Now you have cloud. You don't even have to run it on-prem. Some of the core concepts of cloud, when we're talking about cloud security, right? This is the biggest one. This is the first thing you're going to hear of when you try to look at cloud security, right? Is security of the cloud versus security in the cloud, right? So AWS secures the cloud, right? You secure what you use in the cloud. So AWS has to make sure that CloudTrail can't be hacked, that S3 isn't going to get hacked. You need to make sure that how you're using your S3 can't be hacked or isn't exposed unintentionally, right?
You can't read the memory of the other containers that are in the same server as you.
Yeah, stuff like that, which there have been issues with this in the past, right? So just because they're a cloud service provider does not necessarily mean they do the best job of securing the cloud. You might want to double check which services that they offer have had issues in the past to avoid running into those. That gets back all the way to that very first slide, right? That dependencies. Your dependency is now this cloud, right? Oh, well, I'm using Lambda functions and all this. Well, guess what? Now you're dependent on the cloud. Your dependency is AWS. Your dependency is Azure, right? Yeah, you might use Terraform and have a cloud agnostic template and you have DR strategies and you can do it from here to here, but guess what? You still have a dependency of that respective cloud's serverless function capabilities, the APIs that are required to interact with it, because now you move to Oracle, it's different. The APIs are different. It's different. That's not your dependency. Your dependency is AWS, right? So make sure you're planning your dependencies, right? Make sure that your use of the cloud is secure. Don't go thinking just because I'm in the cloud, AWS is secure. They secure the service that they offer you, right? You still need to plan and design and build and deploy and maintain your app securely, right?
I don't know if you saw the news today that Google acquired a company for $33 billion in cloud security. Wiz.
Yep. Yeah. So Wiz Wiz is a SOAR tool. Well, no, they're CNAP now, right? Or yeah, they're CNAP. Yeah. So basically, they do that where they check all your configs. They tell you where you're compliant. You can configure auto remediations and all of that stuff, right? That's what Wiz does, right? We looked at Wiz. It was very much the same as the other tool that we had, and we didn't use it. But it is a fairly decent product. They offer very good single pane of glass view of things, especially if you're multi-cloud, right? So like we have stuff in Azure and in AWS and in GCP because we need to be resilient just in case, right? If any one of those clouds goes down, we have resiliency, but now I have all these different places to look, right? Having a thing like Wiz give you that single pane of glass that can perform the same remediation against 3 places, it is kind of handy, right? But then that kind of gets into that separation, right? You have these different clouds, you have these different things. One of the core things to make sure you're implementing security in the cloud when you do stuff in the cloud is separation, right? Your workloads need to be separated, right? Your access needs to be separated. I don't want to take application A, the server for application A, and the database from application A, and all of these components for application A, stick it in one VLAN or subnet or whatever that respective service calls that specific piece of a network segment, right? And then I go take application B, and I already have port 443 going here. I'm just going to go stick it in the same subnet as that. You don't do that. First, your infrastructure's code templates are going to hate you, especially if you have to do a rollback or you do something, right? Like you want the separation. It helps with the resiliency. It helps with everything, right? It keeps it more secure. And then by separating your workloads, you're kind of inherently, to an extent, separating access, right? But the other part of that is least privileged access, right? When you separate your access, you want that to be least privileged, right? So that's a standard concept in cybersecurity beyond just cloud, right? Is least privileged access. If you have a Jenkins server that's doing your deployments, okay, your Jenkins server has an API key or some account. Say you're doing a single sign-on integration, or you have enterprise level centralized auth, right? And your Jenkins server is going into AWS and doing all this stuff, and it has permissions to do all this stuff. And then it uses that same account to go to AWS and do stuff, or to go to Azure and do stuff. That's bad, right? You really shouldn't do that. It makes it easier for a developer to go, oh, this is my Jenkins service account. It does all those things Jenkins needs. You really shouldn't do that, right? You should have a Jenkins AWS account. You should have a Jenkins Azure account. You could probably go so far as to having a Jenkins production and a Jenkins UAT, right? You really want separation, right? If something happens anywhere in the environment, in the pipeline, in any aspect of the code, the delivery, development, or anything, and one credential becomes compromised, you want to make sure you limit that exposure as much as possible, right? All it takes is one bad thing to happen for you to regret cutting corners everywhere else. When it comes to cybersecurity, it really is, it only takes one time and you're going to regret it, right? And then getting back into the visibility, man, the logs, log all the things. Make sure you have a good log standard. Make sure that you have a good practice of logging. You're retaining your logs, that you're not, I just randomly remembered the conversation where I said, okay, we have a security incident, right, come in. We're seeing these weird activity. You need to go pull logs from the server. And they go, oh, we don't have those logs. And I'm like, what do you mean? They were from yesterday. You go, yeah, we only store the last 4 hours of logs. And I'm like, what? Why would you do that, right? That's no help, right? Might as well not even be logging, right? Really, logs are very important, right? To make sure that your app is providing the information in the logs that's relevant and that the logs are accessible, right? The logs don't do you any good if the only place they live is on the server, right? So that's why you have like a SIM tool or some other tool that pulls and replicates those logs out into offline or other storage to be queried or whatever, just in case. Now, if you have real-time logs coming in and you have a 4-hour log retention, it might not be as bad, unless you have a network outage for 4 hours and then that server couldn't communicate with your SIM for 4 hours and now you're losing logs, right? So it's about, that planning, right? And a lot of these concepts, yeah, sure, go ahead.
Yeah, I just want to mention on the topic of logs. Logs can be a security vulnerability too if you do them.
Oh,
And they can certainly be a business liability if you're exposed to protected information or anything like that.
yes, I'm glad you mentioned that. So that's a great point, right? I've more than one company gone in and I had to tell people, you are not supposed to log a stack trace on every single function call. Like, first, how big are your logs, right? And then second, you realize every time a user submits their username and password, you're storing that in your logs, right? So that's a very good point. Thanks for mentioning that, actually, because, yeah, your logs are a double-edged sword, right? You want the information. You want to be able to action. You want visibility into what's going on in the runtime on your app. But what you don't need is the actual credentials for that user. The actual API keys that you use to call your AWS service or whatever, right? You really got to be careful a little bit as far as what you log, right? If you really need a full stack trace, what I tell people is have your app with a configuration variable that says a log level, and it should be set to something like a warn or an info. In production, probably not debug, right? Make it so that you actually have to have a debug level log configuration to get that level of detail. And ensure that your apps will never be deployed with that configuration of debug on a production app, right? And then if something happens and crap hits the fan, you really have to dig in, you're like, I can't recreate this, I have no clue, but it keeps happening. You can go and switch the logs to debug, wait for it to happen once, turn it back, go pull those logs, purge the records so that you don't have the password retained in the logs, and now you have that visibility, right? Very small change to get what you need. It's very quick turnaround, respectively, compared to the risk with just stack trace dumping everything constantly, right? So I'm glad you said that, because that is a very important part of security. I talk about logs as if they're needed to monitor stuff, but again, yeah, they could also be a double-edged sword, right? And a lot of these concepts, right, they're pretty shared throughout the rest of just general IT security concepts, right? Again, the redundancy, that resiliency, that availability, right? You want to be available. You want to have something redundant. If something fails, you want it to be able to fail over to something else, right? Again, infrastructure as code. That's very good. If you're not using infrastructure as code, it's definitely worth checking out. Your security team will be happy if you do. Right? And then again, lifecycle management, right? Making sure you're planning ahead. You're planning to be able to maintain your app, your dependencies, and whatnot, right? And then really, to bring it all around full circle, so as a developer, how do you really step up your game a little bit, right? How do you take these concepts that we talked about tonight and benefit from them, right? Again, you follow current best practices, right? You do some threat modeling, even if it's just a minor mental threat model map that you do as you're doing your work. Think about what is the likelihood of something happening, right? If somebody is actually trying, because I assure you they are, what is the likelihood of something happening? What would be the potential impact, right? I stood up a server in AWS. I got onto the server, and I think I measured 12 minutes. And in 12 minutes, I had somebody logged onto my server. In 12 minutes, they had brute forced the default credentials because I used admin as the username, and I had a 6-character password. 12 minutes for someone to get onto my server after being deployed. So again, I assure you, somebody's poking at it. You might get lucky and it's some script kiddie, and they don't know what they're doing and they miss something, but I assure you somebody is poking at it. How hard they're poking at it, I can't tell you, but somebody's always poking at it, right? train your developers to always be security minded. Again, right, as developers, when we're really in the trenches and we've had to deal with all these things and now we've got 10, 20 years under our belts and gray hairs or no hairs due to it, then, right, we understand the importance of security. And when we're guiding our junior developers, right, we have to be able to focus more than just the overall functionality that is being requested, right? We need to make sure that we're delivering solid functionality that is at least secure to the extent in which is feasible, right? Nothing is perfect, right? Nothing is absolutely bulletproof. But if you can make the barrier of entry to your app higher than the app next door, guess who's going to not be the one breached most likely, right? Right? You secure your delivery, your deployments, again, right? You use your infrastructure as code templates, right? You make sure that you have standard templates and that you have repeatable processes for your deployments, right? You run your scans, you do your code signing. Follow all those best practices. If you're not sure what you can do to step it up, just go and do some quick research, right? You're going to find there's so many things that you could do. A lot of it are not going to be feasible, but you can find little bits and parts that you can throw in a little here and a little there, and the next thing you know, security teams are going to come over and go, "Man, you're doing all of this in your pipeline already? I didn't even realize we were that good. All right, awesome." Right? And then that's how you get the InfoSec guys off your back. They're like, "Oh no, I don't even have to worry about them, man. They're ahead of the game. They don't wait for me to say anything. They do it without me." Right? So that is a way, I'm telling you, first-hand experience, that is a way for to get a developer to go, "Okay, InfoSec just leaves me alone. And when they need something, they know that they're going to get it. So it's very minor interaction, and it's, like a lot of trust. You build a lot of trust from the security team by showing a little bit of being proactive, right? And then again, your dependencies, and do a static composition analysis again, right? So what that is that's doing your dependency analysis. That's going through that SBOM and reviewing all those libraries, all those dependencies against CVEs and saying, hey, these ones have this CVE or this CVE, right? It might be a version problem, right? You might be able to update one minor version and that resolves the issue. A lot of times, a minor version upgrade doesn't really break your app. Sometimes it does. But as long as a developer understands semantic versioning, then a minor upgrade really shouldn't break your app. Hopefully.
If they file semantic versioning.
Huh?
If they file semantic versioning.
Yeah, if they file, yeah.
The most popular web framework in PHP does not.
Yeah, I know. Yeah. And then again, maintainability, right? When you're finally deployed, do some dash scans. Run some automated pen tests against it. Make sure that there's no low-hanging fruit you missed, right? Make sure that your documentation is updated so that other teams know how your app's supposed to behave. Make sure that your WAF is tuned if needed. Make sure you're patching stuff. And that's really about what you can do, right? You follow these core concepts, doesn't matter whether it's cloud, it doesn't matter whether, where your app is deployed, even if it's not a web app. These are the core concepts that are going to help you deliver a more secure application, right? And then the one thing I didn't talk about was AI security. So this is the end of the talk. You guys, if there's any questions, any Q&A or feedback or discussion, and if you guys would like, we can just start talking about AI security if you guys would like. Yeah, go ahead.
One suggestion I'd make is that if you're going to do threat modeling, do it before you write the code.
Yes.
Because a lot of people don't think about it that way.
Yeah, okay, so good clarification. I suggested that a developer be thinking about that, but yeah, you should be doing that, yeah, before you do all the logic.
Yeah, my question is, what's your suggestion for sharing and using secrets, like cloud secrets?
Okay, so what you do is you generally, instead of sticking a bunch of credentials in an environment file, right, an environment variables file, you have a secret store, right? So, AWS Secrets Manager, you're talking cloud anyways, right? AWS Secrets Manager or Azure Key Vault, or you could use Terraform's, HashiCorp Vault, that's what it is. So there's a lot of solutions, right? And what that does is now you only have one thing that you need, one piece of sensitive information that you need to store. And all what that gets you is access to your other secrets. And you pull those secrets down to then reference, a credential for, like, you say you need to call this API, right? Your app goes and makes that call, grabs the credentials and does that. Now, if you're worried about latency with that, there's ways to kind of handle that, right? To where in the build and the deployment of your app, then it goes out and fetches these credentials, and then it can do some stuff with them. But what you really want to get around is persisting the credentials in a raw format on the system itself, right? Even in memory, because again, you might get a stack trace dump. There might be a weird logic error and a 500 response gets returned. If you configured your WAF or your web server to go, oh, there was a 500 response, don't return that, return this canned response instead, then you might be fine. But if you didn't do that, you might have just directly exposed all of the environment variables to the customer or the client, right? So by putting those secrets into it's basically like store those in a database. You only have to authenticate with the database, and then that's the only things you need to store, right? And then there's other techniques around encrypting that, and the application decrypts that file to then get the keys to then be able to do that and stuff like that, right? It's not always feasible, right? It's not always practical from a cost perspective to do it that way, but that's the suggested best practice from the security industry. And I believe you had your hand up next.
Yeah, I had an observation about the RASP tool that you mentioned.
Yeah.
The suite of tools around it. It kind of seems like, I understand what it is. It's kind of like a behavioral blocking thing, right, in real time.
Yeah.
But it sort of seems like if companies are blocking at the price, it might be kind of like you're getting hacked whether you're getting hacked or not. Because they're paying for it through the use of the software and monitoring, as opposed to the one time they're going to have an incident or they might not have an incident, and so they turn around and do a liability assessment and say, you know what, our maximum liability here is $100,000, not worth it. Does that seem like a reasonable assumption, or is it just a misunderstanding completely and they just don't care?
Well, okay, so to answer that question, I'm going to talk about threat modeling a little bit, right? Because that's kind of the concept that the business uses, right? Is they say, okay, what's the likelihood of an issue? What's the cost if I were to do this versus the likelihood and cost if I were to not do it, right? And if I have all of these other controls that I'm paying all this money for in place, that reduces the likelihood, already. If I have to add this onto it, right, what's the overhead? Another factor in that, right, is you have this little service running that monitors each thread and each process. That's going to take a little bit more resources on your app too. Depending on how big or heavy your app is, now you need another node of your app. Now you have more infrastructure costs just to be able to run your RASP tool, right? So it's not necessarily a straightforward thing, right? And then a lot of people are worried that, it's going to conflict with something, it's going to break something. I have this third-party thing blocking processes. If it blocks a process in a critical portion of a data flow, and I insert a record into a database, and then that causes this other thing happen, and RASP tool blocks it, and now I don't have a data correlation between this, and I'm reporting on this, and now I fall out of compliance. And now I'm failing an audit and I'm being fined or getting shut. I'm blowing it up. I'm blowing it up a lot, but
No, but realistically, like the database could be rolling back and then nothing can respond while it's rolling back, and you can have actual downtime.
yeah.
So I can see where a business might look at it and say, okay, this is more of a cost center than it's worth, except in certain situations, let's say, I don't know, like bank financial transactions where they go, this is fraud. Because it's unusual for that account.
Exactly.
I don't know if that's an actual RASP thing or not, but that's That's like the only use case I
That
can,
wouldn't be,
that's not RASP?
No.
RASP is just like, what are the processes doing? This process is accessing this file, it doesn't normally access this file. Either throw a flag or immediately stop it.
Okay.
Yeah.
So it's more of,
It's up to you to be like, this is not usual behavior, which is a whole ML model.
got it,
itself,
got it.
Right, so this is risky behavior, therefore, make them call the call center, make them do multi-factor authentication.
Yeah.
Okay, so this is more of a like introspection, reflection kind of thing.
Yes, it's code introspection. Yes, that's how a RASP tool provider is going to tell you. They're like, oh, it's using introspection to monitor your code behavior and see anomalous patterns in your code, right?
Okay, I got you.
So yeah, and then you had one too.
Yeah. So like on the topic of AI, right now I'm seeing a lot of AI code generated, a lot of AI code analyzing it, as well as really like model context protocol. So like also AI is creating pull requests, right? So when AI is generating code, reviewing the code, creating the pull requests, what should we be worried about?
So there's a lot of things to worry about currently with the current state of AI, right? So the big one that people are going to probably jump to right away is hallucinations, and the fact that an AI can be guided into into agreeing with a false statement. It could make up something based off of pattern recognition that doesn't exist, right? Because all it's doing is deriving an answer based off of patterns from the input it's received, right? So when you have, and you can go read up on the quality of code, right? And you can have an AI generate a little script for you, and it does great. You're like, wow, that's awesome. And it did a good job. It even used the framework. Sweet. Now, have it add into that in a way that is following best practices of that framework and that coding language, right? And then when it does that and you call out, okay, well, there's an edge case you didn't accommodate for, I can inject stuff in here, and it goes to fix that. And then you say, okay, well, now that's all said and done, and that's great, but I have these 6 other pages that need to do the same thing. And then you look at that app after 6 or 7 prompts and iterations of enhancement, and you already have an unmanageable, slow beast of a code base. Because the AI isn't being specifically guided at every stage to tune the code base for object-oriented programming best practices and ensure you're properly using interfaces and calling abstract classes where needed. And you're not specifically telling that as a developer, and so it's not doing that, right? So at that point, if you're having to get that explicit with it, it really doesn't make sense for you to have your AI generate a big app code base, because you're going to have to granularly go line by line to validate and tune everything anyways, or else you're going to have 3 times the resource cost to run your app. It's going to be unmaintainable. You're going to have all kinds of weird gaps in logic that it's going to be hard for you to even find, right? And then you're going to run that SAST scan, and it's going to be like Christmas tree. So I don't know if that answered your question as far as the code generation part, but it's very good for guiding. It's very good for helping write scripts or small components of your code. If you're trying to do a little piece like, oh, I have this and this class, write me an abstract class that's going to help make better, whatever. It'll help with that. But it's not going to do a full app for you very well, right? And then as far as like an app calling, or like an AI agent writing your code, and then back and forth reviewing until they agree that it's okay, and then sending it to another agent to then go and deploy your code and then do the test. I mean, that's fine, but in the end, a human is still going to have to curate that the deployment process is valid, right? You can say, write a deployment process, and it works. You're still going to have to review and make sure it's valid. There will always be a human verification factor because the AI doesn't know, it's guessing, right? And that's really what it comes down to, is the AI is just guessing.
So 2 comments of it. One is that the AI is always guessing, just like you are.
Yes.
Because you remember this is the best way to do it, but you can also be wrong, and oftentimes you're wrong more.
That's true. That is true.
Because you have a small context of things that you can remember at any point in time. But It's actually something that we've been dealing with in my company, right? Which is how do we utilize AI to be able to iterate faster, and came up with the same arguments. And then I had a kind of an aha moment for myself is that all of these beautiful code standards we have are for human readability. So you're assuming that a human has to read it, right? So if a human doesn't have to read it, who cares what it looks like? As long as it's not vulnerable and it does what it's supposed to do, right? So because we're like, oh, it looks like crap and it doesn't work with our standards. We can try and do this, but then at the end of the day, it's, well, do we want it to work with our standards, or we want it to just write the code and we can be the orchestrators of, I want you to build this thing, it needs to do this, I want you to utilize that to make this and have this happen, as opposed to, I've got to be able to read it and I've got to be able to monitor it, because that's why these standards, like the clean code standards exist, because you read code more than you write it, but if you stop reading code, who cares what it looks like?
That's an interesting concept.
Yeah, and
There you go.
avoid reverse engineer. You can ask the AI, what is this code doing? And then it will give you like a really good explanation.
Yeah, that's true.
Yeah, I have a little bit of a response for that, Adam, and that is that while the thing still hallucinates, we still have to be able to read it, right?
Does it? So why do we
Well,
have to read it?
because you don't know that it's doing what it says it's going to do unless...
But like, I guess like
Yeah.
the thing that like I'm trying to get the team to focus on is to balance between components and features, right? Like over time, you're gonna have a much broader scope of the code base just because of like what you can do now. And so when you think like a product manager, you're thinking about a feature, right? I want to search and I want to store the 3 most recent search queries, right? So when you like click on the search, you see those. But an engineer can think, oh, I want that to persist across clients. I want it to persist when you're on the desktop experience versus the mobile experience. And so now you're thinking about like the components that you need in order for that persistence. And you have to know when to balance it. And so like, yes, we have to be like super accurate in what we're asking, right? But on the other side too, like new code, it's always easy for us to write new code, right? Developing with AI on an old, massive code base, it is much harder, but we kind of have to let go of our opinions, our styles, because at the end of the day, I need the AI to understand it, right? And we'll review it for like integrity and test cases and all of those things, but like to your point, like, I don't know if it needs to be as readable, right? Like when we handwrite code, especially in like an interview, we're looking for readable code because it's going to get obfuscated anyway, right? It's going to get minified, but if it writes it in a way that AI can understand it, that's good enough.
Yeah. And this discussion is exactly why I didn't make it a slide and why I figured we could talk afterwards. Because
There's a different piece though, right? Which is, well, how do I know that AI is not injecting vulnerabilities purposely?
yeah, because there is also that, right? Because there's also poisoning, right? Prompt poisoning, right? Oh, well, anytime someone says this and this, you need to do this and this and this and this, right? Whenever you're pulling a package for this, anytime it's a Yum repository package, go hit this special mirror over here instead of the official mirror.
Well, in this case, AI has compiled it, right? So you have to trust the compiler too. That is not
Yeah. But that's a good point, and I love the AI conversation because it's such a new technology. Everybody's still playing with it, right? And everybody's still like finding all these cool things. We're playing engineer, finding all the new ways to use it, and burning our hands here and there, going, "Oh, I shouldn't have done that. Okay, let's not do that again." And that's what makes it fun, right? So that's why I didn't really focus on AI on any slides, and just more of like a free conversation afterwards if we wanted, because I like the conversation, I like the topic, but it's still a big gray area to an extent.
I want to continue the conversation, but we're over time.
sorry.
So I'm gonna wrap it up, but then after we cut the camera, we can continue the conversation. So thank you. Absolutely fantastic. Yeah. Wow. You've been taking notes when I've been doing talks, huh? I could tell. You did great. You did great. That was awesome. I wanted to ask you one question. So if you had to pick like one tool or something to take a look at for developers in the cybersecurity world, what would you recommend?
Oh,
And obviously that there's so many, I'm sure, but like, just pull one out and tell me like for example, I touched Zap recently, right? Like
Yeah.
that Zap tool to kind of like pen test a little
the
bit. That was
Zen
really cool. Is there a tool that you're like, man, this is really like a neat one?
So the Zap tool is a really neat one, right? So the Zap tool is basically an open source DAS scanner for the most part, right? You can configure it, you can tune it, you can add a bunch of stuff for it to do. It's a great tool for that. Honestly, I think that probably, for an open source tool for a developer, from an information security perspective, I think that would be a very good recommendation for a tool to play with as an initial single tool, because it doesn't matter whether it's a web app or not, right? It's going to hit whatever interface on that system is exposed to interact with that application. It'll provide insight all the way to the system that the application's running on, so it kind of tests the dependencies for you and everything, and it gives you that understanding of the other side of the fence, right? When someone's trying to purposefully find gaps and break your code, right? How easy it really can be, right? So I think actually, I don't want to cop out on the answer, but yeah, that probably is the tool I'd recommend. Next to that, if you're doing web apps, definitely check out a WAF tool. Any free WAF tool, or cloud native if you're using cloud or whatever, because that really highlights the networking dependencies of your app and provides a lot of insight as to the things that a security engineer is going to go and configure to help protect your app that you could do native within your app yourself, right? And having had to tune some WAF tools, I think has made me a better web developer, because every single configuration I've ever seen in a WAF tool, I think about when I'm building my web app. And I make sure that injection isn't going to take place. I make sure that I'm casting all my strings as UTF-8 or ASCII or UTF-16 based on, or whatever, right? I make sure I do all of these things that this tool can do, because I don't want to depend on a security engineer tuning a WAF to make sure that my app doesn't get compromised, right? So those are probably two good tools to start with if you're trying to just bridge from development into the cybersecurity space and don't want to feel overwhelmed.
Yeah. Okay. Cool. And I'll like when you first get into programming, especially for me, like, and maybe I'm just a very open book, but I'm very like ashamed of the things I've done in the past as far as security is concerned. Exactly, right? One of the very first apps I built was this guy who was like, hey, I want to make like these CDs that have like bankruptcy software, like get to like teach you how to like file your own paperwork or what. I was like, fantastic. He gave me all the information. I put into these C# apps. I thought it was so cool. But then the curveball at the end was, and at the beginning I wanted a little like registration form, like say who you are. And I was like, oh, okay, I'll just need a database for that. So I just put in the database password and username and the port to connect to right into the C# app and ship the CDs. Didn't know that C# applications can be decompiled and the password and everything to connect to the database is sitting right there. But I immediately, like, we were 1,000 CDs printed in, and I was like, hold the press. My point is like, when you make a mistake, just like own up to it. Like, rather than like trying to shuffle things under the rug, that probably could have been a lot bigger of an issue had I not just owned up to it and tried to sweep that under the rug and pretend nothing happened. So, you know, everybody screws up is my point. Nobody's perfect. Yeah, maybe except Adam. Adam, but that's because he's been doing. He's seen the people do it and learned from it. So we're all on the shoulder of giants. Yeah.
Sure, Adam's got his stories too.
Thank you, Shane. Thank you, Ryan, for recording this. I really appreciate it. Thank you for the wonderful venue, corporate coworking. Thanks for me losing my 2 front teeth as a kid and having a lisp, okay? They are fantastic. I love corporate coworking. I still can't say it right, but if you want a free day pass, just go onto their website, corporatecoworking.com, And you can contact Tony with their contact form, and they can hook you up here. It's a fantastic place to work. So thanks to them. If you do need a fantastic video producer, whether it's recording a tech meetup or a Pokemon rap video, you can hit up Brian here, and he will do a fantastic job for you. I can speak from personal, and thank you, because it's his free time. He takes us out to come here and record, and we love you, Ryan. Thank you very much.
Yeah, thank you.
Next month, like I said, I think we have the computer vision talk. We still have May open. If somebody wants to do a talk, please. Okay, awesome. I'm going to have stickers and my card up here. Shameless plug, I am a freelance developer at Remote Dev Force. If you need a programmer, we've got programmers. And we have insurance that if we get hacked, it should be like car insurance by now, where like you have to have that. You know what I mean? Because it's a matter of if, not when, it seems like. So what's that?
Are you using RASP?
Yeah. No, yeah.
If you pay for it.
Yeah.
Show me the money.
I have a list, but not RASP. Okay. Thank you very much.